pigeon on my window. When you like the roof of my window. And it was the scariest thing ever. Yes, and I tried scaring him off, and he just got closer to me. And I was like,
a white pigeon or a white and
a pigeon is a pigeon.
well, there's different.
All right, it's a Friday, so we gotta get going here. Any questions on the homework?
Number 14.
Number 14? You're just making numbers up.
No, I said help.
All right, let's take a look at number 14. Number 14, it's the card game. And it says, instructions, a card is drawn at random. Find the probability the card is of the type described. So 14 says, a red card or a number greater than 2. Mutually exclusive or overlapping? Mutually exclusive or overlapping? To be red and a number greater than 2. Why is it overlapping? Because it's both. You could be red and over 2. So calculate the probability of red. How many red cards are there, Landon? It's your question. There are 10 out of
20.
I hope you're right because I'm not looking at it. Okay, there's probability of A. Probability of B was a number greater than 2. How many cards are bigger than 2? I believe there's 5 cards per, right? So 3, 4, 5. 3 times 4 would be 12. So 12 out of 20. Add, subtract the overlap. The overlap will be how many cards are red and bigger than 2?
22.
Where are you getting that number from? That's not. We subtract the overlap.
Yeah.
The overlap are how many cards that are red and bigger than 2. How many cards are red and bigger than 2?
16.
There are not 16. There's only 20 cards there. Half of them are blue. How many? What does it mean to be bigger than 2? Like, which numbers are you?
3, 4, and 5.
Now look at the red cards.
Okay.
How many cards are 3, 4, and 5? Red than red. Thank you. Minus 6 over 20. Do that math and whatever that is, the answer. 22 minus 6 is 16. 16 over 20 would be what? 8 tenths, which would be 4/5. Am I right? 4/5. All right. And that's what the book says. 4/5 is the answer. Yes.
I need to take Spencer to the nurse. My hand feels like it's gonna.
Well, do you need to stay in the classroom or can you make it to the nurse? All right, 2 people, 1 on each side. Go.
Abby wins.
Hey, walk her down with your arms on her. Okay. Put your arms on her. All right. Yes.
Number 17.
Number 17. Let's see, what game are we playing? 2 game cubes. So how many things can happen with 2 game cubes? 36. Okay. A is supposed to be a probability of the event. B is the odds occurring. Oh, they're making our life hard. Okay. 17. The sum of 8 or exactly 1 shows 6. Okay. Sum of 8.
4 and 4.
They never do that. Always start with 1.
Oh, okay.
1. No, that didn't work.
2 and.
That way you don't skip 1. So 2 in,
6 and 2.
3 in.
5 and 3. 4 and 4.
And that's it. Okay. So 1, 2, 3, 4, 5. So 5 out of 36. Plus, the second one was what? Exactly 1 6 shows. 6 and a 1, 6 and a 2, 6 and a 3, 6 and a 4, 6 and a 5. So that's out of. Okay. So we're good. She's down there.
Yep, she's good.
And now what's the overlap? Which one has both 1 6?
6 and a 2.
There's 1.
2.
There's 2. So there's 2 overlaps. So minus 2 over 36, whatever. Now that's the probability. Odds are how many ways to win, how many ways to lose, right? Here's the cool thing is once you do this calculation, you found how many ways to win. Okay. By the way, what's that turn into?
8 over 36.
8 over 36. We messed up something because it's saying it's 13 out of 36. So what are we skipping? The sum is 8. Did we skip any? No. 2, 3, 4. We got the 5s. So that part's right. We must have. Oh, I know what we did. Because it says a 6 is showing, we only did half of them, right? If a 6 is showing 6 and a 1, 6 and a 2, 6 and a 3, 6 and a 4, 6 and a 5, but it's 2 game cubes, so those flipped.
Okay, so it's
10.
so 13.
Yeah, so 13. Now, how do you turn that into odds? Well, you just figured out how many ways to win. So if this equals 13 over 36, how many ways to win this game?
13.
Okay, how many ways to lose this game?
Not 36. 23.
Mm-hmm. There you go. Now, do they say ways of winning or ways of losing? Oh, it says odds against. So double mess up. So 23 to 13. There you go. All right. I shall collect that at the end of class.
No answers.
Friday, I don't do answers. There's just not enough time. Okay. No joke. Today is an easy day, but boy, is this starting to build up how much stuff we've done. No one individual day, other than maybe combinations, permutations, that's a weird formula. Write this down. No one day is that bad. Today's a nice, easy day. But just remember, we're adding another bit of information, brand new. Another bit of information. Hey, brand new. Notice it's saying star, star, star. Only do, I think there's a C as well, too. Maybe there's a D. I just want you to do A and B. And we gave you a couple of them, so this must be a slightly complicated. It's not that bad. It's pretty easy. I said in class. I watched. I clicked. Okay, I don't like that. The fact there's a 6-year-old kid grading. Click. There's a 6-year-old. He's still talking. Click. There's a 6, and I stopped. They're letting a 6-year-old grade your work.
Exactly.
Bro, I told you it's not real. How are you gonna get like the prizes and stuff? It's literal 6-year-old.
That's when you make a big race car house.
You would have won.
Whoa!
You made a race car house. You would have won because that's what the kid wanted.
Oh yes. Did you?
Look, there's an airplane, Daddy, in the sky.
Was my competition good?
Well, I was expecting to see yours actually being judged.
It didn't.
I know.
They didn't go half or through.
All right, here we go. The words are not very helpful. Let's see, we got mutually exclusive, we have overlapping, and now we have a new one called independent events. Okay, they aren't very helpful. Having a solid resource card and examples is how you pass this test. Here we go. All right, easy class. It's another formula. It's a new scenario. Okay, new scenario. Last few classes, we played one game, and we asked ourselves, what were the outcomes? Right? We calculated that. I mean, that's what we did. We calculated the probability of those specific events occurring. Okay. We played one game, one turn. That's what we're doing now.
2 games, 2 turns.
Eventually. But today we're going to do one game, multiple turns. Okay. So one game, we're going to play the same games, plural, right? It'll be one at a time. Eventually we'll get to 2 games at once. But we're going to take multiple turns. Most of the time it's like 2 turns. Okay. We're going to calculate the probability. So what I'm going to ask you to calculate won't be the confusion. The confusion will be, well, what do I do if we're doing multiple turns? Okay. Eventually we're going to do many games, many turns. Not today. We're just going to do one game, multiple turns today. The big but here is that this comes in 2 flavors when you do multiple turns. Everyone look at the board. Here's the game. You got a bag. It's got marbles in it. It says pick 2 marbles. The but here is, well, what does it mean, pick 2 marbles? There's 2 things that can happen. What do you think meaning pick 2 marbles actually means? What does it mean to pick 2 marbles? What happens after you pick the 2 marbles? What do you do with the marbles that you just picked? Do you put them down?
Yes.
Those are the 2 flavors, those 2 options. You hear that? Option number 1 is, well, you pick 2 marbles, you put them back in the bag. Option number 2 is you leave them out of the bag. You're like, well, what difference would that make? It makes a huge difference in the probability. We have weird names for those, but that's the basic idea. You're going to have a game, and the game either resets itself, that's putting the marbles back in. That means each time you pick a marble, it's the same game. Or what's the other thing that can happen? If I don't put the marble back in the bag, is it the same game? It's a different game. You're like, no, it isn't. I'm still drawing marbles. Yeah, but there's fewer marbles to choose from. It's not the same game that you started with. I'm not sure everyone's paying attention. This is a big one. Today, we're going to be doing everything we've done before, and we're going to be doing multiple turns. Each turn you take, you got to ask yourself, is the game the same or is it different? Because we get different formulas for both ones. Today, we get one of these. Okay? 1 game, 2 turns, that's what we'll spend most of our time on, but it comes in 2 flavors. The first one is, I pick 1 marble, look at it, oh, it's red, put it back in the bag. Same game for the second. I'm still going to draw 2 marbles, but 1 at a time. But I'm putting the marble back in the bag. It's the same game every time I play it. The second flavor is what? That's the first flavor. What's the second flavor? I leave it out of the bag. I don't put the marble back in the bag. It's a different game the second time around. If I draw 4 marbles, it's a different game every 4 marbles. I draw the first one, there's 1 marble left. Draw the second marble, there's 2 marbles left, so forth and so on. We get a different formula for each one. We'll do this one today, this one on Monday. Okay? What's the probability of picking a blue and a red? It's a different game for the second one. It's the same game each and every time. By the way, we already actually know how to do this one for the first one. It's something we've already learned. Okay? Write this down, box 1. Like I said, they're not very friendly words. When the game doesn't change, when it's the same game over and right, pencils, let's go. When it's the same game over and over and over again, we call them independent events. A game where one event doesn't affect the other event. When you flip a coin, does the coin know that the previous time it was heads? How?
Because it has a brain.
Doesn't have a brain? Those are independent events. You can flip it 26 times. It doesn't know what happened. The game of drawing a marble out of a bag and not putting it in is a different game every time. Flipping a coin is the same game every single time. Those are independent events. The game resets itself back to its original shape. Okay? One event does not affect any other event. I don't care if you're grabbing red or blue marbles. You put the marbles back in the bag, it's the same game. The opposite of that, Monday, the opposite of that is called dependent events. It's a game where what you draw that first choice has a whole big influence on what happens the second choice. A game of cards. You're trying to get 4 aces, and you don't put the first draw back into the deck. There's only 3 aces left. The likelihood of you drawing a second ace goes down because there's only 3 aces left now. If you draw 2 aces, the chance of you drawing 2 more are really small because there's only 2 left to draw from. When you're trying to draw an ace the first time, you got 4 of them that potentially 4 out of 52. The second time, there's only 3 out of 52 if you don't put it back in the deck. Today we'll be doing independent events. Monday we'll be doing dependent events. We okay? We have different formulas for both. Like I said, the chapter itself isn't bad. It's just that there's a lot of formulas here. Recall. Recall that we've only ever played one game in one turn. Now we're going to play one game, but we're going to take multiple turns. Remember the counting principle, day one, the little map, and I said, let's go to the movies. Do you remember how you did that? You counted how many ways to do thing one, and what did you do? Multiplied it by how many ways there are to do thing two. That's the formula for independent events. Okay? The formula is, well, don't write this down. We've got a box for it. You figure out how many ways to do the first thing, you multiply it by, notice we're now multiplying, we're not adding. The last couple classes, we were adding things together. For mutually exclusive or overlapping, you add, and remember overlapping, you also subtract. But for independent events, we're going to be multiplying. Write this down. For independent events, this is the formula right here. Just event A times event B, and boom, you're done. Okay, that's not hard. Two numbers. Remember, if there were three events, it would be A times B times C. Just two numbers multiplied together. Today isn't hard. What's hard is, come test day, I give you the scenario. You got to think, wait, mutually exclusive, overlapping, independent, dependent. There's four formulas. You will have to know that. But if you do your homework, you listen in class, it's not too bad. The probability of P and A, B, notice it doesn't say or, P and B, you got to do both. Can't be one or the other, it's got to be both. It's two multiplied together. For independent events, dependent, different formula. Okay. One key word that you should try to find is with replacement. If you see the words with replacement, it means you're putting the marbles back in the bag, or you're putting the cards back in the deck. It won't always have the words with replacement, but many times it will. If you ever see with replacement, it's independent events. Guess what it'll say with for dependent events? Without replacement, right? That means you leave it out of the bag. You leave the card out of the deck. That's the formula for Monday. All right, we okay? Easy formula, right? Two numbers multiplied together. All right, that's pretty easy. You got a bag. It's got 2 blue, 4 green, 3 red. What's the probability of picking 1 blue, 1 red with replacement? Keyword there is with replacement. What you're really asking yourself, does the game change after the first thing, or does it stay the same? And does the game change, or does it stay the same here? Does it stay the same, or does it change? Stays the same. I put the marble back in the bag. Okay, so this one doesn't change. It's the same game over and over again, so we can use the independent probability formula, which is just probability of 1 times probability of the second one. Okay. How do we win this game? What do we got to get? What do we got to get to win the game? We have to pick what? 1 blue wins the game. 1 red wins the game. What's the probability I pick a blue and a red? I got to have both of them. Okay. So I reach my hand in there and I pull out I won the game. Well, how many ways are there to win that game? For blue? 2 out of 7.
Wait.
Is that right?
2 out of 4.
Wait.
2 out of what?
Oh wait, I didn't see right.
I still haven't heard the right answer.
It's 9.
2 out of 9. Do you see that? Anna. Right? Okay, then. It's 2 out of 9. Pick a blue marble to win, it would be 2 out of 9. So the probability of A would be 2 out of 9. Right? Because A would be blue. Well, what would be red?
1 out of 3.
What is it?
1 out of 3. 1/3. Because it's 3 ninths.
If I reach in and I pull out a red one, I win the game, yes? Well, how many red ones are in there?
3 out of 9. So 1/3.
Yeah, okay, I got you. You said 1 out of 9, though.
I said 1 out of 9.
Now I understand why you said that. All right. He was just reducing the fraction, but he wasn't thinking right. All right. So probability of the first one is 2 out of 9. The probability of the second one is 3 out of 9 multiplied. Now, he's kind of right. It would be easier if we had reduced that, but okay. Straight across, what do we get? 6 out of
1 out of 6.
6 out of not 9.
Oh, wait, you want that?
And 100. And we reduce that by 3, we get 2. 3 goes in 81. 20. 27 times. Who's lost? You haven't said anything today. I'm worried about you. All right, I can tell.
Yeah.
All right. Coin tossing. Hey, before they even say anything, I already know. Coin tossing, is that independent or dependent? Does the game stay the same or does it change? Coin tossing is always stays the same, right? Unless there's some weird game like you toss 4 coins and every time you pull 1 coin away, okay, now the game changes. But just the fact of flipping the coin, hey, that game stays the same. Hey, what's the probability you get heads? Oh, we got 2 things, a coin toss and a die is rolled. Hey, when you roll a die, does it change or does it always stay the same? No, I meant like the game. Is it always the same or does it change? All right, rolling die, flipping coin, and almost you'd have to have a weird game for it to change. Hey, both of these are independent events. Does the game change after you toss a coin? Absolutely not. Coin, it still has 2 possibilities. Okay. All right, so this is independent events. Cool. All right, so what is the probability? Let's see. A was the coin. B was the die. So what's the probability of getting heads?
Very small.
What is it?
1
Is Jace the only one that's going to give me answers today?
1 over 2.
What's the probability of getting an even number?
1 over 2. No. Wait. Yes.
Yeah, but let
Three
Jaden, let everybody think it through though.
Oh, I guess that is.
I know, and I was defending you as well too because Jaden was already reducing. So probability of getting heads is 1 out of 2. The probability of getting even is 3 out of 6, but Jaden was thinking ahead. He's like, well, that's a half. So it's 1/2 times 3/6, right? Which gives us what? Which is, and if we had reduced like Jaden recommended, 1/2 times 1/2 is 1/4. All right, you got to stop me. No one's saying I'm confused. I'm worried about this class. Usually by now I've got confused people.
Yeah, today's Friday. We're all tired.
All right.
So probably it was the people.
What's this one say?
Without replacement.
What does that mean without replacement?
Without replacement.
Well, then how are we going to calculate this?
Well, you gotta subtract everything.
We'll see if you're right on Monday. But if it says without replacement, in other words, if the game is changing, we don't know what to do. We got to wait until those are dependent events. Hey, everyone stop what you're doing. I'm losing focus in the class. Pay attention. Next class, I'll teach you how to do this one. It's a different formula. Okay, it's not that hard, but it's a different formula. All right, coin is tossed and the die is rolled. What's the probability of heads or 4? You should be able to do this in your head. Heads would be,
1/2.
a 4 would be,
1/6.
so therefore multiply 1/2 times 1/6. No,
It's 1.
1/2
I took the 4.
times 1/6.
Yeah.
1/12.
I thought it was 4.
Because there's only one way to get a 4 with one die. 1 out of 6. Okay. So 1/2 would be the probability of getting heads. 1/6 would be, multiply those across. Clearly some people can't do that in their head. 1/12. Time. How many 4s are there on a die? That's how I got 1/6. It's a game cube. It's a dice. Die. 6 sides. Okay. All right. See if you can do box 3. See if you can do box 3. Grab your pencils. Angie, stay motivated. Exactly the way I described it. A marble is drawn and replaced. Same or different game? Same game, so it is independent events. Independent events, yes.
I'm confused.
It's just the probability of the first times the probability of the second, if it's independent. So what's the first event? Describe it. Okay, so how many ways to win that game?
2.
Out of? Keep going.
Oh.
Okay, and then the second one. Oh, I'm smart. I have a brain on my.
Abby, are you with me? Or are you dead too? Probability of red was what? 2/5. The probability of blue was. So then what's the answer? 6/what? All right. You guys have made more mistakes today on simple multiplication than I've ever seen you ever make. We're almost done. All right, box 4. Here we go. There's only one side of the page. We're already on box 4. All right. Hey, it's the marble game again. A marble is drawn and replaced. So does the game change or stay the same? I'm going to say this is where you'll make your mistake come test day. Listen, please. Listen. Listen. Where you'll make your mistake come test day is that it's not going to be today because it's like, oh, I just take the first thing, multiply by the second thing. The problem is on test day, sometimes it's going to say with replacement. Sometimes it's going to say not with replacement. It's 2 different formulas. Kai, what's the first game we're playing here? What do we got to get? Just read. It's the first thing we got to get. Okay. First one's red and the second one is red. So what's the probability I get red? Because there's 5 red marbles, right? Yeah. Okay. Where do you see it say 5 red marbles? All right, somebody else. What do you got, Amber? What's the first game we got to play? We got to get a how many? Out of? And the second one? What is the second one? Second one is what color? Remember, we put the first red one back, so the second time I reach in there, how many red marbles are there? Say again? I reach in there, I pull out a red. Look, I won, but there's what? 2 out of 5. But I put it back in. So the second time I reach in, how many red marbles are there? Okay. 2 out of. Therefore, it's 2/5 times 2/5, which is
3, 4.
what?
How did you get 2 things?
How many marbles are in the bag?
5.
That's where the 5 came from. Doesn't matter. What wins the game? I want to reach in and I want to draw 2 red marbles. So the first time I reach in, well, how many ways to win that game? 2. Because there's 2 red marbles out of 5. And then I put it back in.
But you got 2 fifths.
Agreed, because there's 1 game, 2 turns.
Yeah. That's like
1 game, 2 turns. Turn 1, turn 2. The first turn, I'm trying to draw red. Hey, I drew red. Well, how many ways to win? 2 out of 5. Okay, put it back in the bag.
You have a mistake.
Second turn. What?
Or you have a mistake on the 6th.
Which one? Box 6? All right, we'll get there when we get there.
So if it were like if you took it out of the bag, it would change.
It would change. We'll do that on Monday. All right, box 5. Here we go. We're on box 5. There's only 6 boxes. Coins tossed twice. Does the game of flipping coins ever change? It's not going to say with replacement, without replacement for coins. You have to know that flipping coins, the game stays the same. What's the probability that the first is heads and the second one is tails? First game, what are we trying to get? What's the probability of getting heads? Second game, what's the game?
Tails.
What's the probability of getting tails? So it's 1/2. Therefore, the probability is you got a 25% chance of flipping a coin twice, getting 1 heads, 1 tails.
So that's 1/4.
1/4.
This is always done.
Hey, what's the probability of flipping a coin 5 times and getting nothing but heads?
Yeah.
5 times, nothing but heads. The first time, what's the probability for the first flip? Second time,
1/2.
third time,
1/2.
fourth
One
time,
1/2.
fifth time,
1/2.
2 times 2 times 2 times 2 times 2.
That's 2 to the 4th power.
That is 2 to the 4th fifth power.
5th power. 16.
2 times 2,
4, 8, 16, 32.
1 over 32.
Oh.
Okay. Somebody calculator. What's 1 divided by 32? And then make it a percent. You get 5 heads or tails in a row. The probability is
3.1.
3%. You got a 3% chance of getting 5 heads or 5 tails in a row. Okay. Those are not good. Notice when he said odds, those weren't odds. That was probability. If we had 1 over 36 as the probability, what would be the odds? This is how many ways to win. This is what can happen. So what are the odds?
1 to 36.
No. How many ways to win?
1.
Hey, how many things can happen if we flip the coin 5 times? Well, the first time, how many things can happen?
2.
Second time?
2.
2 times 2 to the 5th, which is 36. But remember, odds in favor are how many ways to win versus how many ways to lose. Not 36, 35. So it's 1 to 35. Will be odds in favor of flipping a coin, getting heads or tails 5 times in a row. All right. Last one. Apparently I have a mistake here. Let's see. You have a deck of 52 cards.
Deck AA.
Oh, I see it. Okay, thank you. You have a deck of 52 cards. You draw 1 card, replace it. So dependent or independent. This is independent. So with replacement. And then you draw a second card. What's the probability of picking red on the first and then a 10? Red on the first and then a 10. Red on the first and then a 10. What's the probability of drawing a red card?
1 out of 52 chance.
Absolutely not. There's only 1 red card in a deck of cards?
It's 26 or
26 out of 52.
times 4 over 50.
How many 10s are there?
Oh, that's right.
So you take
Oh, but we can do a little cross multiplication, cross reduction here. Hey, 26 goes into 52.
1 and 2.
4 goes into 52.
1/2. You're asking the wrong person. You're asking the wrong person. I can't do that math in my head. Oh, 126. That's what I thought.
126.
I know.
Oh, I didn't. Oh, look at that. That all for nothing. All right, questions. What time do we get out of here?
Now,
I don't know.
like,
I still haven't memorized Friday's schedule.
I just do that with the
2 minutes. Hey, you guys were like bumps on a log today.
Hey, at least we got our stuff done.
What?
At least we got stuff.
We got it all done. Uh, coming around to collect homework. Smalley's coming around to put your homework in the box. Do not forget to put your homework in the box.
Mr. Charrier.
Kai, are you gonna make it?
Wayne, come back, come back.
Can I show the class my builds?
No, I don't have time for that. Donovan, any questions?
I
No.
Donovan.
No.
All right. By the way, not to scare you, but here is a list of, and I left off the formulas for combinations, permutation, and odds. Here is everything that we have so far in this chapter.
Okay, thanks.
Have a good weekend, Donovan. We'll see you on Monday.
Okay, bye guys.